Here in this video, let us look into the topic called as areas of parallelograms and triangles. So now let us look into the general properties of areas of parallelograms and triangles. Coming to the first property, it says that a diagonal of a parallelogram divides it into two triangles of equal area. Now quickly let me show you what it means. Parallelogram ABCD, let us assume here parallelogram ABCD, and say we have a diagonal here. AC is the diagonal. Now what this diagonal does to the figure ABCD is that it splits this into two triangles of equal area. That's what it does. And this is very specific to the quadrilateral, which is called as a parallelogram. So now the area of the triangle ABC is equal to the area of the triangle ADC. That's exactly what the first property means. Now let us go to the second property. The second property says that parallelograms on the same base and between the same parallels are equal in area. What you have to notice here is it is a plural. Parallelograms on the same base. So say let us have a base here, AB. Now let us draw many number of parallelograms on this. Say we can draw this. Alright, and also what we will do is it says that parallelograms on the same base and between the same parallels are equal in area. That's what it says. So we will draw another line on top which is parallel to the base AB. All we need to make sure is these lines are parallel to each other. These are parallel. All the same color lines are parallel to each other is what we have to make sure. So now let us name these differently. Say for example, A, B, C, D, E, F, G, H, I. That was the random naming. So now if you see, if you take ABGD is a rectangle which is a parallelogram. If you take AFIB and if you take AEHB or if you take ACFB, all of them are parallelograms of equal area. Why? Because they all lie on the same base and in between the same two lines that are parallel to each other. So that is what the second property says, and this is a very important property as far as the problem solving is concerned. The next property states that the area of parallelogram is the product of its base and the corresponding altitude. Now say for example, let us draw parallelogram ABCD. If you take ABCD, its base is AB and its altitude is nothing but it is a perpendicular line drawn on that base. The perpendicular line drawn on the base and touching the opposite line as well. Or this is the altitude of the given parallelogram. Or even this can be the altitude, this also can be the altitude. Everything has to be at 90 degrees to the base and also 90 degrees to the opposite line. If it is 90 degrees to the base, it will naturally be at 90 degrees to the opposite line if the given figure is a parallelogram. So I'll read it again. The area of this figure is nothing but the product of its base. That is, if AB is 10 centimeters and altitude is 5 centimeters, the product would be 10 into 5, which is 50 centimeters square. So that is the area of parallelogram. Let us see what does the other property say. The other property says that the area of a triangle is half the product of any of its sides and the corresponding altitude. Now say for example, we have a triangle ABC. It says that the area of this figure ABC is nothing but half the product of any of its sides and the corresponding altitude. Now say for example, if you take AB, any of its sides, take AB and then take the altitude corresponding to AB. The altitude corresponding to AB would be a line drawn from AB and touching the other vertex. This is the altitude of this triangle. So the area of the triangle is nothing but half the product of any of its sides and the corresponding altitude. So it is half into AB into, say let us name this D, it will be CD. So half into AB into CD in this case is the area of the triangle. Or we can take, if you take CB as a side, then join this vertex to CB, then this will become the altitude. So then it becomes half into CB into, say if you name this E, then it will be AE. So this is how you find the area of a triangle. Let us now move on to the next property. So now the next property states that if a triangle and parallelogram are on the same side. Okay, say now let us draw AB. Okay, and then say let us draw another parallel line to AB. Let us name this CD. If you draw a parallelogram here and then name this ABFE, and then if you draw a triangle now, something like this. So now if this triangle, say let us name this AGB, if this triangle AGB and ABFE, if they lie on the same base and in between the two same parallel lines, then the area of the triangle would be half of parallelogram's area. That is what it means. So say the area of triangle AGB will be area of half of ABFE. So this is also another very important property. The last property states that the area of a trapezium is half the product of its height and the sum of the parallel sides. Now say for example, let us draw a trapezium. You know how a trapezium is. This is how a trapezium is. It is formed between two lines that are parallel to each other and the other sides are non-parallel to each other. So this is something like a trapezium. In fact, this is a trapezium. Say let's name it ABCD. Now how do you find the area of the trapezium? Area of the trapezium is nothing but half the product of its height and the sum of the parallel sides. So say if this is 10 centimeter and this is 20, all you have to do is half the product of its height. The product of its height. The height would be the distance between the two parallel lines. Say the distance between the two parallel lines is around 6 centimeters. So it will be half into 6 into the sum of the parallel sides. That would be 10 plus 20. So it will be half into 6 into 30. So that will be the area of this trapezium ABCD.